দেখা যাচ্ছে কিনা দেখো তো।
जी सर।
Sir.
মুভ হচ্ছে?
Yes, sir.
ওকে। Okay. So let's start uh, our today's class. So today we will discuss about earthquake. So the first question may arise: what is earthquake? Okay. So this is a very common term, earthquake. That means the ground shaking. Okay. Simply, it's the shaking of the ground surface or the earth surface. So this so the next question, and what is the source of the energy? Okay, or what is the reason behind this sudden shaking of earth surface? So this is due to the sudden release of the energy, okay, in the earth lithosphere that's create the seismic wave. Okay, basically the earthquake is felt due to seismic wave. So consecutively we'll know how the seismic wave is generated, and how many types of seismic waves are working behind an earthquake. So the on a single earthquake can be different sizes, okay, so and different range or intensity. So sometimes there may be very small shake or so weak earthquake that many of you can't feel, but in some cases it may be higher intensity. And so for the seismicity or the seismic activity, uh, for an area, suppose for Chittagong or Dhaka or any area, so seismic vulnerability or seismic activity, these will be defined in terms of the frequency. That means how frequent the earthquake occurs in those areas, types of earthquake, size of earthquake. Size means the intensity and magnitude uh, over a period of time. That means last 100 years. So for the considering the vulnerability of an area, we will consider the its frequency. That means last 10 years or last 50 years, how many earthquake occurred, and which sizes, the maximum sizes, minimum sizes, what will be the time interval, etc. So one basic theory of earthquake. As we discussed already, that the earthquake is due to the sudden release of energy. So how this energy is released suddenly? As we discussed earlier, that due to the slip of the tectonic plates along the fault line, this energy is released. That means the earthquake is generated at those point, the slip surface. And the next question: so how this energy is released? Okay, as the sleep is gradually, a sleep occurs gradually, so there is no option for sudden release. But in reality, this phenomena is defined by elastic rebound theory. uh, this is by uh, Henry Wright, and professor. He provided this theory. This is the elastic rebound theory that is very similar to a stressed rubber band. Okay, suppose you are stressing a rubber band up to a certain limit, so it stores potential energy. Okay, so when you cut this elastic rubber, what will happen? The stored elastic energy in the rubber band, that will suddenly released. Okay, suppose you are stressing a rubber or any elastic materials, and then you cut it. Okay, so this energy will release suddenly, and will give you a thrust. Okay, so the similar process is applicable for elastic rebound theory of earthquake. The earth crust is gradually stored elastic stress. In this case, earth crust will store elastic stress that will release suddenly during an earthquake. Actually, when this energy is released suddenly, the earthquake is occurred. So here is a illustration of elastic rebound theory. So let's start from the bottom. In this pen, suppose Pacific plate and North American plate. These this is a fault line. Okay, this is fault line, and these two plate initially at the starting these two are in line. Okay, so before earthquake, with the passage of time, while these two plates are moving compared to one another, suppose North American plate is fixed and Pacific plate is moving upward. Okay, or this direction. So while it's moving along this fault line, the fracture will be occurred along this fault line. So before earthquake, if we consider it is an elastic, the medium is elastic. So here, this zone, in this zone there will be a stored energy, huge energy, elastic stress will be stored. And at certain point, when the limit will goes beyond the allowable limit, or excess the allowable limit, so there will be sudden break in this elastic stress, break of elastic stress. And after earthquake, these two plate will be isolated. And during earthquake, this sudden energy will be released, and due to this sudden energy release, the earthquake will be filled. Okay, so this is the basic principle of elastic rebound theory. And now, due to this earthquake, during earthquake, different types of waves, earthquake waves will filled. Actually, the ground shaking will be filled due to movement, of due to the traveling of seismic waves. So when an earthquake takes place, mainly two types of seismic waves are generated. Two types of wave. One first one is the body wave, and second one is the surface wave. So what is body wave and what is surface wave? uh, if we simply discuss, suppose this is our earth, this is core. Okay, this is surface, and all of these, this portion, this is body. Okay, that means the inner body of earth, this is body. So the waves that will pass through the body, so these will be called as the body wave, and those will pass through the surface, that will be termed as the surface wave. Okay, so what is the basic mechanism? Suppose at this point, suppose this is a fault line. Okay, this is a fault line along these two plate. Suppose at this point earthquake is generated. And so from this point, many different types of waves will be propagate. Okay, the wave will be propagate from this point. So suppose one wave will comes in this surface. Okay, from body to surface, and thereafter these, all these waves that pass around the body, those will be termed as the body wave. And once a single few waves made travel through the body and reach in the surface. So what will be next step? These body waves will come to surface, and thereafter they will move through the surface. Okay, they can move through the surface. So these waves are uh, surface wave. That means at first stage, this body waves will generate, and thereafter surface waves will be generate. So among these two categories, body waves are two types: P wave and S wave, primary wave and secondary wave. And the surface waves are also categorized as two part. One is the Rayleigh wave, R wave, and the lab wave. That means L wave. Okay. So let's start one by one. So here is the visual illustration of the P wave. Okay. This is known as the primary
স্যার
wave.
বডি ওয়েভস আর সারফেস ওয়েভসটা আরেকবার বুঝালে একটু ভালো।
Okay. I think surface waves. I think this is also in my lecture. Surface wave and body wave. Okay. So look at this. Look at this animation. I think it's clear now. Okay, the waves that those are coming through this path, that means if this is the propagation point, the waves those are moved through the earth. This is the surface wave, body wave, and those more travel through the surface of the earth. These are the uh, surface wave. Okay.
Yes, sir. Thank you.
Okay. So let's try to understand the different types of waves. Why? What is the characteristics of these waves? And based on the different characteristics of these waves, the vulnerability as well as the nature and the other things will be vary. First of all, p wave. Okay, so this is known as the compressional wave. In among all waves we will consider two things. First one is the direction of propagation, that means wave propagation, the direction of wave propagation. And if you consider in the three dimension, so direction of wave propagation, and another important point is the direction of particle movement. Okay, these two points, actually the variation will be occurs in these two points. So P wave is known as the compressional wave or the longitudinal wave. These types of waves are known to all. This is the compressional waves, like the sound wave. Okay, sound waves is the tension compression. That means this is transferred through. Suppose this wave is propagated in this direction. Always the particle movement is in the same direction. That means suppose if we consider this block. Okay, so these particles are moving along the direction of the propagation in the same direction. Okay, so it is a series of compression and dilution. That means series of compression, dilution, compression, dilution. Thus the wave is propagate and travel through a materials. So this is the fastest wave that for any earthquake. That means if we record the earthquake waves by suitable device, we'll discuss the name of the devices later. So if we record the earthquake waves, the fastest wave will be the P wave. Okay, this is a tension compression, and its the typical velocity along the earth crust is 6 kilometer per second. So this is the fastest one. And the another characteristics of POF that it can travel through both solid and liquid or gases. That means our earth inner mantle and the crust core will contain different types of gas, liquid, molten magma, and some cases solid portion. So this is a combination of solid, liquid, and gases. So the POF, this can move through any media. Okay. And the POF has the less impact in the ground surface movement for both the solid and rocks resistance, compressional, and dilution effect. That means these lines indicate that while it's moving through the uh, earth crust, that means there's a body wave. While moving through the earth crust, most of the earth portion, the solid portion, and the solid rocks, soil, and the these solid portions, those are resistance to compressional and dilution effect. That means these wave have the less effect. Okay, so let's move to the next one. The surface wave, secondary wave, that means S wave, or sometimes known as the shear wave. This wave is important. Shear wave. This wave is recorded immediately after the surface wave, so primary wave. It's sometimes known as the transverse wave. Look at this animation, 3D animation. Here, the direction of propagation, the this is like wave shape. Okay, that means uh, something like this sinusoidal wave. Okay, this is the wave propagation. And in this case, The particle is moving, is rest in its position, but it's moving opposite direction. That means perpendicular direction, upward direction. Suppose if this is the wave propagation direction, and the particle is moving ups and down, okay, in that direction. So uh, this causes sharing deformation. That means if you consider at this stage two consecutive particles like this, okay, if we consider the mesh, okay, finite element, finite mesh. So if you suppose these two element, this one and this one, so while wave is moving, okay, wave is moving, the propagation and the particle movement is ups and down. That means if you consider these two consecutive particle, after movement or after facing the s wave, the particles is, suppose one is moving downward and another is moving upward, okay, or vice versa. So this is the characteristics. And for the solid media, the particles will or the medium will faces the shear. This is the characteristics of shear, okay. So the particle will or the media along with the SOI will is propagating, this will faces shear stress, okay. First one, previous one, those will faces the compressional stress, or in this case this will be shear stress. But as we know, the liquid or gases, those have no or shear resistance, okay. That means the liquid and gases, those are not facing any shear stress, and there is no shearing resistance. So the S wave can only travel through the solids. That means only the solid portion of the earth earth in inner crust and out body, those can carry the shear wave. That means if any shear wave is traveling, and if it faces in a zone filled with liquid in the earth crust or the gases or any void, in those cases the wave will be uh, zero, okay, the wave will be vanished at that point. The typical crustal velocity of shear wave, this is around 3 kilometer per second. And the soil and the rocks, the soil, actually the soil have the less shear resistance usually compared to the compressional resistance. So and shear wave, as wave travels, as the velocity is less, so the s wave travels more slowly compared to the p wave. And while we record, the first wave recorded is the p wave, and thereafter surface wave. And the soil, in terms of shear resistance, the soil is very weak in shear. Therefore soil is strong in compression, but it's weak in shear. So therefore the S wave have the typical greater impact and in the ground surface movement compared to the primary wave,
স্যার
okay.
স্যার আমাদের এস ওয়েভ স্যার লিকুইডের মধ্যে যদি ঘটে তাহলে কি ঘটে?
Okay, so this is the illustration, okay. If S wave comes, what will be happened? uh, S wave velocity drops to zero, okay, when the core or mantle have the liquid portion, okay. Suppose this is liquid portion, this orange portion, this is the liquid portion, okay. So consider this is the propagation point, and S wave is coming here, here this is moving, okay. So and each and every wave have its wave path, okay. So in its wave path, suppose one wave come directly to this point, so and it faces a liquid zone, liquid core or mantle. So in this point, this in this point, the shear wave will be dropped to zero, okay. And this is known as the Gutenberg discontinuity. That means suppose this, if this is the point of propagation, the point of earthquake generation, up to a certain portion of earth at other side, the S wave will not be filled. That means the S wave will not cannot come. Suppose parallelly, if the point of propagation is here, the S wave can only travel through a certain area. That means for this point, it will cover only a certain portion. Okay, so this is the Gutenberg discontinuity. And the next one is the L wave, commonly known as the lab wave. This is very similar to the S wave. Okay, uh, because there is also transverse shear. Okay, but in this case, this is very similar to S wave, but the direction of propagation is also same, but only the difference is the transverse shear. Okay, that means uh, in lava wave, the secondary wave, the wave will propagate along the z direction. That means vertical, and in this lava wave, this is uh, horizontal shear. That means the particle motion is different. Direction of propagation is same, but the particle motion is uh, in y direction. That means sideways movement. That means transverse shear. Okay, and these waves are actually transferred through the ground surface. And next one is the rally wave. Um, this is very similar to the surface ripples produced by a rock thrown into the pond. That means if you drop a rock or piece of rock in a water, a pond or river, or in any stagnant water, what will happen? It will face um, these types of motion, and the particles will faces something like torsional motion. That means suppose this is a particle, this will rotate. Okay, so this will face a rotating motion. In those cases, the ground surface is faces vertical and horizontal displacement. Okay, the previous in the previous cases, it is either one direction, either a horizontal movement, or either vertical movement, or the transverse movement, shear movement. Okay, but in the rally wave, it will propagate in such a way that the the soil particles will face the vertical and the transverse displacement as well. So next is the for some other important terminologies related to earthquake engineering. The first one is the hypocenter, then epicenter. So already we know that the earthquake is propagating along the fault line. Okay, so this is one plate and this is another plate. Along these two plate boundary, this is the fault line. Okay, so this is our fault line, and the earthquake will occur at any point at any depth along this fault line. So at which point the energy is released, that means stored elastic energy is released. So this point, suppose so this point will be known as the focus of earthquake. That means the hypocenter. Okay, and the ground and from this point the earthquake waves will be generated and radiating outward. Okay, in all direction. That means from this point, in all direction, earthquake waves will be propagate. Okay, so this is the hypocenter or focus. And the next one is the epicenter. This is very common term to us because it is in the earth surface. So hypocenter and epicenter. Epicenter is the point in the earth surface directly above the focus. That means suppose this is focus, so if we go perpendicular to this direction, and we will find the epicenter. Okay, so these are the, and the next one is the seismograph. So the most of the cases earthquake caused by release of the energy due to the sudden displacement along the fault line. So the major earthquake characteristics by build up stress and then sudden release of this stress in the along the fault ruptures. The seismograph is an instrument looking very compared to this. So these instruments records the earthquake waves with respect to time. That means in this direction of the seismograph, this is the time, and y direction, this is the amplitude. Amplitude means the displacement amplitude, surface displacement amplitude. So this is an instrument, seismograph. Seismograph is an instrument, and those record such types of graphical representation of any earthquake during the seismic wave generated by an earthquake, and the actual record of ground shaking from the seismograph, this is known as the seismogram. Okay, the two term, the seismograph and seismogram. So the device is known as the seismograph, and this representation, this is the seismogram. Okay, this is seismograph, and this is seismogram. Okay, and in seismogram, here is an arrangement, the free pendulum the attached with a needle. So while the earth is moving or ground is shaking in this direction, as this is a free pendulum, and here is also a rotating drum with a certain speed, the drum is rotating. So the pen will record freely, as it is a free movement, the pen will record such types of movement and amplitude. Suppose the first one will be the P wave, and thereafter S wave, and so on. And as we show earlier, this is the record of this is the record of how the seismogram record the earth waves. The recording will in terms of time. And generally, the P wave will suppose the P wave will come first. So at the very beginning, the intensity of P wave will be higher, and thereafter, like this, the P wave starts to come, and one times it will come in peak, and thereafter it will amplitude will be null. Okay, and thereafter the second wave. In second wave, again you will find another peak. Okay, so you can easily understand. Okay, now S waves are starting at those point, and thereafter the intensity will again release, and intensity, more or less the intensity will uh, reduced, and again when again you will find another large peak. Okay, then you can decide, okay, now this is the time for surface wave. Okay. So this is the sequence: the first the primary wave, thereafter secondary wave, and last, at last the waves will be comes around, those will be the surface wave, because the surface have the less velocity, as well as the it needs to travel a long distance. Okay, that means first it will comes from body to surface, and thereafter it will travel along the surface. So it need to travel a long distance. That's why this is the sequence of earthquake, recording the earthquake waves.
স্যার এখানে বোঝা কিভাবে যাবে যে সারফেস ওয়েভটা স্যার র্যালি ওয়েভ না স্যার লাভ ওয়েভ স্যার?
Okay, this is quite difficult. In generally, it's can be noted as surface wave, but which one is Rayleigh wave and which one is lava wave, the identification is quite difficult. This uh, may be classified based on the damage, or the recording of intensity or previous experience. But in general, actually these all of these are the standard cases. Okay, so in general, in practical, the earthquakes are never in sinusoidal wave, or in a time function wave. Okay, in general, those are actually very abrupt earthquake waves. So the next term, how
Sir, sir, I have a question, sir.
okay,
Sir, মানে বাংলায় বলি স্যার, মানে যে মানে প্রথমে স্যার পি ওয়েভ আসে, তারপর স্যার এস ওয়েভ আসে স্যার, সর্বশেষে যে সারফেস ওয়েভটা আসে স্যার,
Hmm.
মানে এগুলির ভিতরে টাইম স্প্যানের কি স্যার অনেক বড় বড় গ্যাপ থাকে নাকি স্যার, মানে
No, no,
নর্মাল
time
5-10 সেকেন্ড বা 15 সেকেন্ড এরকম?
very small. Okay, look at this image. Okay, here. So this is the starting time 0. Okay, so if the fast record of P wave. Okay, the P wave starts to coming, and thereafter more or less equal. The intensity of P wave, as it is compressional tension also, the P wave is more or less equal. And after 24 second, okay, this is in real the image, real seismogram. So after 24 second, another large peak. Okay, so this is another large peak. Okay, so the at this point we will decide, okay, this is the starting of the S wave, and in this case the difference is only 24 second between S wave and P wave. Okay, so actually as the velocity is very high, okay, along the of these waves, so in this is very difficult to isolate. Okay. And next one, how can we locate the earthquake? That means the point of an earthquake. So if, as we know the amplitude from the seismogram, we know the amplitude, and there have some empirical equation to calculate the distance of epicenter from the seismogram station. That means the seismograph devices are located at many points in Earth. That means suppose one is in Chittagong, one is in Dhaka, or any point. So the you may you can only find the distance. That means from these earthquake data and seismogram data, you have the scope to calculate the distance of epicenter from your station. That means suppose consider for the green circle. So this is your station. Okay, and you can, after earthquake is occurred, you can calculate from this graph amplitude, time, travel distance, everything. You have the scope to calculate the distance. But if we consider the distance, suppose this is distance, so the point can be anywhere along the if we consider this as the radius and draw a circle, taking the center as this station. So this is the green circle. So the point of epicenter can be any point along this periphery of this green circle. Okay, so how can we find the exact point? Okay, in this case, to locate the an earthquake, we need at least three seismograph station. Three seismograph station, and consider the next one, another seismograph station. This is in the red circle. So for this seismograph station, and we similarly we calculate the distance of epicenter from those station based on the data collected on those point, and thereafter we draw another circle. Now it can be this point or this point. Okay, any of two. Thereafter, we will select another station, that means third station, and similarly we will draw a circle. And the intersecting point of these three circle is the tentative position of epicenter. Okay, so this is the technique to locate the epicenter. So this method is actually I already discussed. This method is known as the triangulation method for locating the earthquake. Okay, that means triangulation means you need to select three station in a actually okay, three station. This is not in point actually. Sometimes this is looking like triangle. That means three station and then three circle. Okay, so the intersecting point of these 3 point. um, Triangle. Okay, another criteria is if you take all these station in a line. Okay, all these station in a line, this is also not possible. Okay, in some cases this may also not possible. So the three station must be in a triangular position. So this method is known as the triangulation method of locating the earthquake. And the next terminology for the earthquake, this is the magnitude and intensity of an earthquake. Okay. So when we consider or analyze any earthquake after it's happened, uh, we will decide the strength of an earthquake based on two parameter. The first one is the earthquake magnitude, and second one is the intensity of damage. Okay. So the magnitude is means the amount of energy which released from the earthquake. So this is the measurement of energy. Okay, that means it's something related to energy. And the intensity is based on directly based on the visual inspection. Okay, that means the damage of the buildings, how many buildings are damages, how many properties are damages, how many people are died, etc. And the reaction of people, that means if it is felt by people greatly or not. That means along this the visual inspection, there is an intensity chart. We will discuss hopefully today. So based on this intensity chart, we will decide, okay, the earthquake intensity is 1, 2, 3, 4. This is categorized as in some parts of numerical number along with some description. Okay. So suppose after one earthquake, you need to take the survey, field survey. And based on the people's reaction, number of building damaged, etc., based on the visual inspection, we will decide the intensity of earthquake. And the magnitude, this is different. This is in terms of this is a mathematical, in terms of mathematics. That means based on the amplitude, ground movement, etc., and any other things, we will decide the magnitude. So to calculate the magnitude, there are three main types of magnitude scale. First one is the local magnitude scale, surface wave magnitude scale, and the moment magnitude scale. So in those all cases, there have some empirical equations. So um, the first one is the local magnitude scale. This is the Richter scale. In 1935, Charles Richter from Caltech, he developed this scale, magnitude scale, uh, for the shallow and local earthquake. Okay. And often nowadays we often this is very popular scale, and we it's known as the Richter scale. This is very common, Richter scale. In Richter scale, this is in logarithmic scale. So the range is 0 to 10. This is a logarithmic scale, and most commonly used, this is an equation, log a by a0, local magnitude scale. And a is the maximum trace amplitude recorded by seismogram. That means that has a natural period of 0.8 second. Yeah. 0.8 second means the 80% damping. So these are some complex terms. So you not need to memorize all of this, or not need to understand at this stage. At the advanced level of earthquake engineering, we also discuss the damping ratio, damping of a building or any other materials. Each and every materials have a damping. Damping is a very common. We use the door damper. Okay. So the function of door damper is to, if I close the door, this will the door or damper will absorb some energy. Okay. So that means the seismogram is generally also takes some energy, or it also absorbs some energy. So for those cases, 80% damping is considered. So this is A is the maximum trace amplitude, and A naught is an, and the zero of the local magnitude scale, which is arbitrarily fixed. And this is a more or less fixed common constant value, 0.001, corresponding to smallest earthquake. Okay. So this is the local Richter scale, and another is the surface wave magnitude scale. This is another scale is based on the amplitude of surface wave having the period of 20 seconds. That means for a surface wave, those having, we will record up to 20 seconds. Take the record of the 20 second, and the amplitude, maximum amplitude will be taken. This wave have this scale have an advantage over the local magnitude scale. Those use the the local wave use the maximum ground displacement. Okay, rather than maximum trace amplitude from a standard seismogram. And this is used for the moderate to large earthquake, and this is the typical equation. Where is the A prime is the maximum ground displacement, or del is the epicentral distance from the seismogram. Okay, in degree. So if all of these informations are available from any seismogram. And next, last one is the moment magnitude scale. This is another scale, um, and this is useful for any size of earthquake. Um, and this is based on the earthquake moment. Okay, momentum of earthquake. And here M0, that's the seismic moment in terms of momentum scale. First of all, we need to calculate the seismic moment, and mu is the shear modulus. Shear modulus in generally, the soil have the very common soil have that some typical value of shear modulus. AF is the area of the fault plane. That means, suppose each earthquake is occurred due to the sudden movement along the fault line. So a certain area will be slip. That means, suppose this is a fault line in cross section direction, and after earthquake, this suppose 5 mm or 10 mm, or some cases 1 meter. Suppose 1 meter is slipped, and in transverse direction, that means in transverse direction, the length of along the plate boundary, what is the length? So if we multiply this the displacement multiplied by length, so this will be the surface slip area. Okay, so this can be calculated, and d is the average displacement of rupture segment in the fault. That means, um, in the observed area, this is the average as strike slip area or displacement. So along with all this data, the moment magnitude scale, in the moment magnitude scale, along with all this data, the magnitude is calculated. And now, comparison of this magnitude scale. So if we place all these scale in a single graph, so what will be happened? Proceeding all these three scale, in some cases taking the average, some cases the geologist or earthquake engineers take the average of all three scales sometimes, but consider all those scales. But in reality, if we place all these graphs in a single paper, and this is sometimes found that magnitude close to 7 or below 7. Okay, the magnitude level below 7, and all in any scale, suppose this is 7. Okay, in this point, all those have the negligible variation. That means the lines are very close to each other. So if we express an earthquake as 7, suppose 6.5 or 6.8, anything. So the scale is not so important, because in either scale the variation is very low. That's why sometimes the earthquake magnitude are sometimes reported without referring to specific magnitude scale. Okay, in general trend, this is very evident to mention the scale, because only the in scientific community, only a numerical value, this has no significance. Okay, but in these cases, sometimes this is reported without reference scale. This is mainly due to, as is discussed from previous one, the three magnitude scales gives a very close value. In three scales, the values are very close for a certain earthquake, up to the 7. And sometimes the scientist takes the average value of 3. Okay, and sometimes also the seismograms, in general, many of the countries and many of most of the parts of the earth may have not the oil installed seismograph stations. So sometimes, based on the feelings, based on the damage and other time response, time history data, The previous those are compared with the previous earthquake, and then magnitude is defined. Some thumb or a reference based on some previous references, the earthquake is sometimes defined. And the next term, or next topic, is the intensity of an earthquake. As I discussed earlier, the intensity is based on the observation, visual inspection, observation of and observations of damaged structures, public feelings. Okay. Also, some secondary effect. Actually, the earthquake may have different types of effect: uh, landslide, soil liquefaction, ground movement, and some individual person responses, and extreme cases, tsunami. Okay. So there are many occurrence or many consecutive steps may come. So this intensity can easily be determined in urban areas, but for rural areas this is very difficult. And the most common intensity scale, this is the modified Marshall intensity scale. The scale is looking like this: the modified Marshall intensity scale. The intensity level 1 to 8, 8, 9, 10, 11, 12. Okay. The intensity scale is 1 to 12, categorized in terms of 1 to 12. And intensity level 1, this means the people's reaction no not felt except by a few people under especially favored circumstances, and the damage. Okay. So the people feelings and the people expression, this is also sometimes depends on the position. That means if you are walking along a road and the earthquake is occurred, so you have a different feelings compared to those are working in office or working in a seventh floor or sixth floor. Okay. In a single earthquake, in an earthquake 2016. Okay. And maybe in 14 April 2016. So I was working in a private organization, and this is at evening around 6 to 7 p.m. So we are sitting in seventh floor. Okay. So although the earthquake is not so high, at previous earthquakes we faces in Kuwait or any other positions, or we are always in the ground level. Suppose sometimes in road, or sometimes in our dining hall or room, any other, those are in the ground level. But at those specific cases, my feeling is completely different from the previous earthquakes. Although the magnitude may be lower or higher anything, but the feelings and expressions, because while a building is moving, suppose this is a building, so if you are in the ground surface or ground level, and if you are in the top floor, or if in the top floor or the seventh floor. Okay. If you're in the top floor or seventh floor, your feelings is definitely different from those one in the ground floor, because while object is moving, the displacement, suppose this is the ground shaking, so the building will move like this. So the building is moved like this. Okay. So your feeling is okay, I am traveling a long distance along the sidewise. Okay. And in those cases we feel that the ceiling fans are moving, the water bottles are moving, the frame of the wooden frame of the building, that means the door, window, those are also we hold the structure, and those are moving in our hand. So the feelings is completely different. So this is the people reaction. And the second intensity, this is the two, only by pumps, and the with the increasing of the intensity, this damage and reaction is also considerably increasing, and up to 3 there is no damage. Okay. And intensity level 2, there is no damage, some object may swing. And the intensity level 3, there are standing motor cars may rock sliding. That means the motor cars may slide some, or tends to moving. Um, And parallelly, the people's reaction is increasing. That means the field of the quake is noticeable by the indoor, especially on the upper floor of the buildings, and the vibration is like to passing a track or duration of the earthquake may be estimated. Okay, sometimes while a track is moving along the road, and if you're sitting in a building in upper floor of in a building along this road, so due to the movement of vehicle and some vibration is felt. So if the feeling is such types, so the intensity level is up to 3. Thereafter, um, the intensity level 4, the damage will be like the dishes, window, door, or those are the disturbed. That means due to certain movements, if you go for kitchen, you will find that okay, the dishes are displaced, the windows and doors are maybe cracked. Okay, so these types of walls may make cracking sound sometimes. Wall during earthquake, as the brick walls have no resistance, only the filling walls. So these types of walls are sometimes faces a crack, visible crack. Okay, in those earthquake in 2016, after earthquake occurred, we found that the visible crack, visible hair crack in our in those buildings. Although this is not in engineering aspects, this is not damage at all, because for the frame structure, that means beam column structure, the damage of or hair crack in the uh, partition wall, this is not so important. And industry level 5, those reaction is filled by nearly everyone. And next one, intensity level 6, and thereafter intensity level 7. In those kinds of reaction, everyone's runs outdoor. Okay, that means some earthquakes is felt by everyone, and and people are try to moving outdoor. So this is the termed as the intensity level 7. And related to comparative relating damages are the negligible damages in the building and good designs and construction, slightly moderate damage in the wall, well built ordinary structure, and considerable damage in poorly built or badly designed structures. uh, some chimneys are broken. Okay, this is the intensity level 7. Thereafter intensity level 8, 9, 10, 11, and 12. Okay. Um, and the last one, I am discussing the last one, intensity level 12. The reactions, the people reactions, the waves are seen in the ground surface. That means a visible wave. Okay. The line of slide and the wave are distorted. And damages, the total damages with the practically all work construction greatly damaged and destroyed. Objects are thrown upward into the air. So these are the maximum point intensity level 12. Okay. And next, this is the common earthquake effect. Some surface rupture after an earthquake. Look at this image. These 2 points are actually in the same point, and due to the sideways movement, approximately 2 meter. This after an earthquake, these 2 points are moves away approximately 2 meter. In all other cases, so it is another example of surface rupture. So this along the fault line, all these things may happen. This is the effect of ground shaking. That means structural damage. The breeze, structure, buildings, all of these may damage due to the earthquake. And another common effect is the liquefaction. So liquefaction is a complex phenomena in advanced studies of earthquake. This is actually a single subject of study, liquefaction due to the earthquake movement. So suppose you consider our underlying layers, as we discussed earlier. So the underlying layers are composed of different um, rock. Okay, this may be sand, sandstone or sand type sediment. This may be clay sediment or maybe hard rock. Okay, so the clay type or The sand types materials only for this is liquefaction is very common for the clay, because the sand can easily release water. So suppose you take a soaked or soaked sand, and if you press the sand taking in your hand, squeeze it, water will release very quickly. Okay, the water is released very quickly from the sand. That means this is an condition. And another condition, think that you are taking a clay, and the clay have the less permeability. That means it takes too much time to release the water. Okay, so when an earthquake is occurs due to the ground shaking, that means this is very similar to the squeezing. Okay, very similar to squeezing of the ground surface. So due to this, the water the water in the those underlying layers, those will feel some pressure, the pore water, and along with this excess water, pore water pressure, and the soil will for a certain time, small period of time, the soil is working like a liquid. That means the water is coming out, and due to this, the soil have no resistance. Then that means immediately the soil lose it resistance, and it will acts like a viscous liquid. Okay, so as the that is lose it shear resistance, and it acts like a viscous liquids, the objects, the buildings overlying this may collapse. Okay, the if it occurs in the road, the cars may may fall in such condition. That means this is no longer a ground. Okay, this is like a mud, and this is like a viscous materials. So this is an effect of and this is the effect of tsunami, the last one. Okay, this is the tsunami. This is the effect of tsunami. While earthquake is propagate in an ocean bed, that means oceanic plate. This is the effect of the tsunami may occurs. We will discuss tsunami in details after the earthquake. And the another effect of earthquake is the landslide and debris flow. So while in the mountain belt, the earthquake is occurred, the materials along with heavy rainfall. If these natural disasters occur simultaneously, thus these types of landslide debris flow this may occur during the landslide. Due to the high due to the heavy rainfall intensity, the overlying layers have huge amount of water. Okay, contains huge amount of water in the soaked soil. And while the movement is rapid, sudden movement is occurs, those portions collapsed and flow along the valley. Okay, as this is a sloping surface, and the valleys are always sloping. So along with those valleys, there is a huge amount of debris materials, and this is known as the debris flow. Huge amount of debris materials flows along the valley, along with water, foreign materials, liquid, and plant, etc. So this is the another disaster, landslide. And our next topic is the earthquake structural damage. Actually, in this course, geology, we only discuss some the basic parameters of earthquake, basic damage and effects, etc. We are not discussing any scientific or engineering background on how the propagation of P wave, how it is the expression, Fourier transformation, etc. So those are actually for the advanced learning. We are simply taking the ideas and hints of the earthquake, the basic knowledge. And you in the successive years, that means in third year and fourth year of study, you will also learn the how to calculate the earthquake intensity, ground acceleration, and how to calculate the and the bracing system, seismic resistance of earthquake structure, etc. So the structural damage of earthquake, which is the based on the strength of shaking, length of shaking, type of subsurface condition, and the type of building. Okay, these four are the basic things. That means uh, what is the intensity of earthquake? That means strength. Sorry, not only intensity. The strength of earthquake, the length of earthquake, the shaking, that means the time duration, if it is 3 second, 5 second, in sometimes the low intensity, low magnitude, but the if the time is larger, so the damage may higher. Okay. uh, Again, the types of subsurface condition, that means subsoil condition, and that means the underlying layer, is it sand or clay or rock, hard rock. The behavior or damage will be completely different. Suppose you build similar or same building in two location, same design, structural design, construction, everything is same, but based on the subsurface condition, as there is a chance of liquefaction or any other thing. So based on the subsurface condition, the damage may vary. Again, the type of building, that means the shape of building. The if suppose if you have a tall building, okay, you have some like tall building. So if the movement is occurs, ground movement is occur, so this will tilt this direction. Okay, sidewise movement. Okay, as due to its own mass, if it tilts beyond a certain limit, it will turns to fall. Okay, due to the gravity, or due to its own momentum. But on the other hand, if you have a building like this, okay, so these building have more stable compared to this one. Or if you have a building like this, like our department, you have a building like this. This is hollow, and this is the building. So these have the more stable in case of ground shaking. Okay, so these are some basic building types. And this is actually the part of mathematics, that's simply showing the shear wave. So this is for a frame structure, how to calculate the shear force, base shear, shear force, overturning moment, etc. These are the part of the dynamic response of building while introducing the earthquake. The shear force is decreasing continuously with the increase of the height, and also the earthquake susceptibility. This will be depends on the irregularity of building, overhanging portion. Suppose if any building have a cantilever portion or overhanging portion, so those have a great overturning moment and a large susceptibility compared to others. And some moment resisting frame typically come from float diaphragm supported overturning. Mm, that means beam column structures, our conventional structures, those are the moment resisting frame. That means beams, columns, all are connected to each other. That means there is not free movement of moment. That means the joint or fixed joint. So this is the moment resisting frame. Okay. And shear wall, this is another types of earthquake resisting wall. The shear wall is the lateral wall, the most commonly used in the lift core, or sometimes for the large heavily loaded building. The RC shear walls are used. Shear walls are actually large size of column, simply large column. Okay, so as the shear walls are the rigid body, so this is an excellent structural system for earthquake resistance, because as it provides more resistance compared to column. Okay, so this is another types. And the braced frame, that means suppose this is a frame. Okay, single frame. If earthquake movement occurs, these have the chance to move this direction or this direction. But if it brace it in the diagonal direction, diagonal bracing, so now what will happen? It's restricted the movement in the sideways direction. Okay, so this is the braced frame. Okay, and nowadays the advanced diagonal bracing elements are found. Those are actually the damping system. That means in not a rigid bracing. Instead of rigid bracing, and the diagonal damper are used. So the function of damper, those can move or slide. Okay, so it allows the building to sway up to a certain limit, because if you completely restrict a frame or a structure, while it will come to its breaking point, you will not get any um, signal from the structure. There will be sudden collapse. So due to this, the damping bracing is sometimes used. So this allows some displacement, and you will get some allowable time. And another one is the structural irregularity, vertical regularity and horizontal regularity, floor diaphragm, etc. So a vertical regularity means each and every floor or should have the same types of arrangement, same types of load. That means in our country we have a common practice to take the basement open for the car parking. So this in this case the vertical irregularity is not maintained. Okay, so this is an very common example. In a ground floor there is no wall. That means this is completely open space, and thereafter in top floors the arrangement is different. So this is the example of irregularity. So up to this we have we complete the our discussions on the basic earthquake related terminologies. Now, and next class, hopefully, in next classes, hopefully we'll discuss our other topics related to earthquake. That means tsunami and the seismicity of Bangladesh. That means we already we discussed the basic of earthquake, basic how its magnitude, intensity, etc., damage, how it works, etc. And thereafter we will discuss the scenario of Bangladesh. For Bangladesh, what is the scenario? Yes, earthquake susceptibility, etc. The previous major earthquake. Okay, the fault lines, active fault lines in Bangladesh, and the tectonic map, also the tectonic map of Bangladesh, seismic activity in Bangladesh, seismic zoning in Bangladesh, etc. So hopefully in next class we will discuss all these things, and thereafter we turns for our next topic, tsunami. Okay.
স্যার
Okay, bolo.
অ্যাসাইনমেন্টের তো স্যার একটু বললে ভালো হতো স্যার।
আচ্ছা, অ্যাসাইনমেন্টটা আমি আর দিচ্ছি না, তোমরা একটু নোট করে নাও। প্রিন্সিপাল রক ফর্মিং মিনারেলস, তোমরা মোটামুটি 15 থেকে 20টা রক ফর্মিং মিনারেলস এর নাম লিস্ট ডাউন করো, যে ইগনিয়াস রক, সেডিমেন্টারি রক, মেটামরফিক রক, এই ধরনের রক ফর্মিং মিনারেলস কি কি ধরনের মিনারেলস আছে। সাপোজ ইগনিয়াস রকে কি কি ধরনের মিনারেলস থাকে, এগুলা প্রথমে নামগুলা নিয়ে নাও। দেন তোমরা হচ্ছে তার কালার কি, স্পেসিফিক গ্র্যাভিটি, হার্ডনেস, যে ফিজিক্যাল প্রপার্টি গুলো আছে যেগুলো আমরা পড়াইলাম, এই ধরনের প্রপার্টি গুলা, স্পেসিফিক গ্র্যাভিটি কত, হার্ডনেস কত, কালার কি, ইলাস্টার কি, কোন স্পেশাল বিহেভিয়ার যদি থাকে, কেমিক্যাল কম্পোজিশন, এই ধরনের স্পেশাল অনেকগুলো বিহেভিয়ার থাকে যে মানে আইডেন্টিফিকেশনের জন্য, এরকম যদি কিছু ইফ এনি এরকম থেকে থাকে, প্লাস আরো যদি কোনো প্রপার্টি তোমরা অ্যাড করতে চাও, তোমরা গুগলে সার্চ করলে পাবা। তো সেই ধরনের যদি থাকে তাহলে সবগুলা মিলে মোটামুটি অত ছোট ছোট প্যারাগ্রাফ হবে, এরকম তোমরা লিখে ফেলবা। এই ওপেন, এটা আসলে তোমাদের করাচ্ছি এই জন্য তোমাদের ফাইনাল এক্সামে মোরলেস থাকে প্রিন্সিপাল রক ফর্মিং মিনারেল হচ্ছে তোমার থাকেই। সো এটা হচ্ছে তোমার ইয়া করবে আর কি, লিস্ট ডাউন করে ফেললে। হ্যাঁ বলো।
স্যার একটা লেকচার 6 এ মেবি স্যার স্লাইডে স্যার 14টা 14টার মতো দেওয়া আছে স্যার, এগুলার বাইরে স্যার আরো এক্সট্রা অ্যাড করব
হ্যাঁ,
স্যার।
আরো বাইরে এক্সট্রা অ্যাড করতে হবে, নট নেসেসারি এগুলাই ফলো করতে হবে। আর অনেকগুলা মিনারেলস থাকে, তোমরা একটু সার্চ করে দেখো। হ্যাঁ, আমি যেগুলো দিলাম এগুলো আসলে একেবারে যে প্রিন্সিপাল তাও না, এর চেয়ে মোস্ট কমনও থাকতে পারে। একটু ইন্টারনেটে সার্চ করে, এটা ইজি কাজ, নেটে সার্চ করে করে তোমরা একটু জাস্ট সামারি করো, বুঝা গেল?
স্যার তার মানে হচ্ছে যে স্লাইড বাদে যা কি যে 15 থেকে 20টা আছে এগুলো লিখতে হবে।
হ্যাঁ, স্লাইডের গুলা তো থাকতেই পারে, কারণ এগুলো কমন কিছু আছে। এর বাইরেও তোমরা তো মাথার মতো করো, নট নেসেসারি যে এই 14টা নিতেই হবে এরকম না, এর বাইরেও তোমরা নিতে পারো, এখান থেকে 2-4টা থাকতে পারে। এটা পুরোটাই তোমাদের ফ্রিডম, ঠিক আছে? মোটামুটি কারণ হচ্ছে প্রিন্সিপাল মিনারেল, বা তোমরা অরোরার বইটা দেখতে পারো। হ্যাঁ, বইয়ে অনেকগুলা মিনারেলস এর নাম আছে, ওইখান থেকে তোমরা কিছু সুইটেবল নেম পিক করতে পারো, করে সেখান থেকে তোমরা লিখতে পারো, এই তো। বাট বইয়ে একটু ডিফারেন্ট ডেসক্রিপশন থাকে, তোমরা তোমাদের মতো করে ডেসক্রিপশনটা লিখবা। এটাই।
স্যার অ্যাসাইনমেন্ট কবে জমা দিতে হবে?
আচ্ছা, অ্যাসাইনমেন্টটা তাহলে আমি টাইমটা বলে দেই। ক্লাসে কি সবাই আছো? 101 জন আছে। আচ্ছা, সবাইকে একটু জানাইয়া দিও, আমি দেখি ক্লাসরুমে ঢুকলে লিখে দিব। অ্যাসাইনমেন্টটা ধরো আজকে 27 তারিখ, তো আজকে হচ্ছে স্যাটারডে, তাহলে নেক্সট স্যাটারডের মধ্যে অ্যাসাইনমেন্টটা জমা দিবা। ঠিক আছে, আমি সানডে হোপফুলি দেখবো, স্যাটারডের মধ্যে জমা দিয়ে দিবা, কারণ হচ্ছে নেক্সট উইকটা তো যেটা ক্লাস নিচ্ছি না, তো এই উইকটা টাইম থাকলো তোমরা লিখে ফেলবা।
স্যার এটা কি এমনি মানে খাতায় এইভাবে লিখবো? আপনি প্রথমে বলছিলেন যে ছবি দেয়া লাগবে বা এরকম।
টাইপ করতে পারো, হাতেও লিখতে পারো। যাদের এখন কম্পিউটার নাই তারা হয়তো হাতেও লিখতে পারো, যারা টাইপ করতে পারো করো। বাট যদি মাইক্রোসফটে ওয়ার্ডে করো তাহলে অবশ্যই পিডিএফ করে দিও আমাকে, বা ওয়ার্ড দিলে হবে, আপলোড এটাই দাও। রোল নাম্বারটা দিবা, হ্যাঁ, ফাইল নেমটা রিনেম করে দিবা রোল নাম্বার দিয়ে। এরপরে হচ্ছে
স্যার এমনি হাতে লিখে দিলে হবে না স্যার? মানে আমাদের তো অনেকের পিসি নাই স্যার, তো আগে যেভাবে দিতাম পিডিএফ বানায় মানে
হাতে দিলে হবে, হাতে লিখে পিডিএফ করে দিলে হবে। বাট যাদের ল্যাপটপ আছে তারা চেষ্টা করবে একটা ইমেজ সহ দিতে। দ্যাট মিন্স সাপোজ তুমি একটা মিনারেলস এর নাম লিখবা ফেলসপার, তো ওইটার যদি পারো, এটা তো একটা অপশনাল, ম্যান্ডেটরি না, যারা আছে দিতে পারো। তুমি হচ্ছে ওই ইমেজ সার্চ করে পাইলে একটা ইমেজ দিয়ে দিলা, এটা অপশনাল। আর হাতে লিখলেও হবে, যে যেভাবে দাও, ঠিক আছে? তো ঠিক আছে, মোটামুটি তাহলে আমরা ক্লোজ করি আজকের ক্লাস। অ্যাসাইনমেন্ট সাবমিশন ডেডলাইন হচ্ছে নেক্সট স্যাটারডে, ঠিক আছে? আমি সানডেতে দেখবো, তো তোমরা নেক্সট স্যাটারডের মধ্যে অ্যাসাইনমেন্ট গুলা জমা দিয়ে দিবা। আমি ক্লাসরুমে ক্রিয়েট করে দিচ্ছি। ওকে,
স্যার অরোরা বইয়ে কি কোনো পিডিএফ আছে?
অরার বইয়ের পিডিএফ আমার কাছে নাই, তোমরা নেটে দেখতে পারো, পাইতে পারো, নেটে সার্চ করে দেখো।
ওকে স্যার।
ওকে।